Hello, everyone. My name is Esko Pekkarinen. I'm from Tampere University of Technology. And we've been developing this open source IP-XACT tool. It's called Kactus2. Please raise your hand if you know what's IP-XACT. That's good. That's good. How many of you know what's Kactus2? Even better. Great. So today I'm going to talk about what we've been doing for the last year. Last year in ORCONF we were kind of introducing what's the tool, and today's talk is kind of follow-up on that, describing what are the latest updates on the tool. So I'll have to touch briefly on IP-XACT and what it is, what's Kactus, but I'll try to be brief. In 2014, the new standard was released, and that caused a massive update in the tool. I'll describe some of the biggest changes in the standard. If we have time, I will demonstrate our new memory designer tool. We made some, it's more of a quality of life changes to our variable generator. Then we'll briefly look at the roadmap, what's coming up, what's the future plans, and I hope we have time for the demo. So what is IP-XACT? IP-XACT is a standardized form for exchanging IP, independent of the vendor, independent of the tools, independent of the implementation language. So it describes how do you formalize an IP block, how do you describe a SOC design, and with the latest standard, it has almost 800 elements of XML, almost 250 attributes. So it's fair to say it's a rather complex standard. And it's not really easy to take into use as you're first looking at it. You don't want to read, that's 200 or 300 pages of a standard. So to help that, we started developing Kactus. It's mainly targeting for easy reuse of the components. And we wanted to prioritize 4 things in everything within the tool. So first of all, as an hardware engineers, I think we have already seen too much of tools that just aren't usable. They are slow, they're really hard to use, they're complex. So we wanted to prioritize usability over everything else. It has to be easy to install, it has to be easy to use. The philosophy is that the user is never lost with the tool. It's always you know what you're doing. Second point is it's always stable. We're not wanting to rush any features. We want to introduce them kind of conservatively, and whatever we introduce, we want to make it as stable as possible. We want to be compatible. There's no reason to have standards if we are not respecting the standards. And finally, coming back to the usability point, the tool has to be helpful. It has to show what's wrong in your design, what's wrong with your component. And you don't want to see that 3, 4 steps later in the design flow. You need to know it as soon as possible. So since the first release in 2011, we had roughly 12,000 downloads. It doesn't sound much, but considering it's a tool for a really narrow field, I think it's really good. Something I want to point out in this analysis taken from OpenHub is that Kactus is currently about 80 years of effort put into it. We're already past the 500,000 lines of code mark. And I think that's something. It's far from a simple application. So what are the changes the new standard actually introduced? Well, in the standard itself, it introduced a huge amount of configurability within the standard. So the field values, most of them can now be described using system Verilog expressions. Some of the elements can be made conditional. So we can, for example, add and remove registers according to the configuration. And something that was missing in the 2009 standard is propagation of values through hierarchy, something we're used to when we're working with traditional hardware description languages. Then they introduced some new elements. I'm not going into details, but just mentioning they introduced catalogs as the new top-level element and some other smaller elements within the existing structures. And then they refined some of the old structures to fit better into this configurability and parameterization. So in terms of Kactus2, this meant actually a huge effort to get everything that was described in the new standard. And around ORCONF last year, we started the update to the newer standard, and we spent over 1,500 hours of work to get it working, mostly on the data models, the editors, and the generators. And this was simply due to the introduction of expressions and conditionality in the standard. It also gave us an opportunity to improve the structure of the code, do some refactoring, and better structure. What we also did at the same time, we improved the validation against the standard and taking into account the design rules set within the standard. So this will help us immediately point out what's wrong with the current component or design, so we don't have to wait that 3 steps in the flow when the compiler tells us something is wrong and trace that back to the IP-XACT. So if I remember correctly, the change there we introduced was something like 90,000 lines of code. So coming back to one of the biggest new features is the memory designer. And the problem the designer faces is the registers are defined locally within the components for better reuse. But their final addressing is actually dependent on the connectivity of the design. And to determine this, we have to travel through all the hierarchy in the IP-XACT and figure out what are the final addresses. And to help this, we wanted to introduce a tool, a new view in the tool that helps the programmer and the designer see what's the final address information, everything in one place. You don't have to go through the individual components, how they are connected. It's all there in one place. One of the objectives is that there's one place where you can see if the memories are overlapping, if there are gaps in the address space, and if some parts of the design are disconnected. So touching briefly on the existing generators and Verilog in this case, we had to change it to go through the design hierarchy because of the changes in parameter propagation through the design. And this also allowed us to generate the complete product Verilogs in one run. Earlier, you had to go level by level and generate multiple times to get the whole hierarchy done. One of the problems around IP-XACT has been that there aren't really public examples available, and I think it was in the first talk in the conference that Mr. Gupta said that it has to be easy to get started. You need good examples, you need good tutorials to get started. And that's kind of outside our tool, but something we're trying to address as well. So we set up a GitHub project to gather some very basic examples, how to get started with IP-XACT, how to get started with our plugins if you need custom plugins for the tool. So we provided the templates for easier access into getting the plugins done. And another very interesting project we're now working on is actually packaging Pulpino with IP-XACT using Kactus. And that's kind of the first good example we want to provide the community with. It's non-trivial, it's something everyone should be able to check out of the GitHub and look at how it's done. The idea is to provide a good example, good best practices, and when we've been asked for public examples, so far we had to say that, sorry, there aren't any. But once we get this done, we can always point them into this and say, hey, look, there's Pulpino, look at that. That's a great example to get started with. So we come from designing embedded systems mostly. So that's where we started the development for the tool. So we had to start with the basic building blocks, the components, the designs, how they're connected. We wanted to ease the transition into IP-XACT by providing import methods for VHDL. Now we have support for Verilog. And then we released the plugin API, so you can introduce your own plugins. A lot of the past 2 years has been working on the parameterization and configurations that the new standard actually helped us. We were already looking at this before the new standard was released. We saw the problem there already, and the new standard gave us a standard way to handle most of the problems we had then. So currently, we have adopted most of the new standard. We have released the templates for plugins. We're working on the examples, and we're working on the new memory designer. We're always looking at new generators, what we can produce out of IP-XACT. And if you look at the roadmap, you will notice that other things we have listed there to come, they're actually not that much IP-XACT related. They're usability related. They're related how do the users want to use the tool. So for example, we had a case where we wanted to use the tool with multiple users, and that was really tricky to do. So we want to improve that aspect as well. And finally, we're looking at if there's possibilities for visualization, for better visualization using 3D, for example. So I think I have time for a short demonstration, and I thought I'd show you the memory designer since that's something that's completely new. The new standard is embedded in the tool, so the changes, if you compare it to an older version, it's not that huge. most of the time you will find fields saying you can insert an expression here instead of a plain value. So I think the more interesting part would be if we look at the memory designer. All right, seems like I cannot clone this, but what you are seeing is a rather standard design in IP-XACT. So on the far left, we have CPU core up there, connected to a bus component that connects the CPU to the peripherals. And now the question is, if I wanted to use this, what are the addresses for the individual peripherals? Remember, in IP-XACT, you define the registers and the memories within the component, independent of the design. So if I run the visualization tool, it'll show me this kind of view. So on the far left, you see the address space defined in the CPU. That's kind of the placeholder. This is what the CPU is expecting to find. And on the right, you see the listing of the registers and memories defined within the components, within the peripherals. And unfortunately, I think it's too small for you to see, but if I zoom in, you should see the individual register addresses are shown for each register defined within the components. And if we scroll down, we'll find there's something wrong here. So I have deliberately mapped ports A and B to the exact same address. And just by looking at the diagram quickly, you will see there's some problem with the memory design. So I'll have to mention, this isn't final version yet. This is something we're working on, but this is something it will probably look like. And if we keep scrolling down, once the address space ends, we will find all the registers and maps that aren't currently connected to any address space or any CPU in this case. So just by looking quickly at this view, the designer should have a good idea of what's there still to be done, what's wrong, what needs to be fixed. And eventually we want to add some editing properties to this, so you can quickly just see that this memory map is out of place. So you go to the source, you change the addressing there, and come back here, and you will see it has changed to the proper location. So I think this is a good time for questions.
Thank you. Hi. Does Kactus2 support component generators and abstractor generators using the type generator interface?
Currently, no.
I have two questions. First, is it Windows only?
It's also for Linux.
Second question, if you said there are no good examples, then who is using it actually?
I am. So some of the companies we know, they use them, but they're really hesitant to give out their IP, of course. So can't mention names, but we do know several even bigger companies that are using it.
Well, as you are from Finland, there is Nokia. So I
Can't
guess it's a research project, and you're working on the tool, and those who are putting money from the commercial side are using it, and therefore there are no public examples.
Well, it kind of comes down to the, I think the problem with confidential IP. They don't want to release even the IP-XACT description of them. So I will say that there is the example provided by Accelerator who's upkeeping the standard, but even they have said there are some issues with that example.
So one more question here. So you said there is a lot of vendor extensions that use Xilinx and others, and that's also what I've seen. So like I think Xilinx uses the IP generator is IP-XACT files. So can you parse them? Can you make meaningful stuff out of them, or is all the interesting things inside the vendor extensions?
Well, that's kind of the two sides to having extendable standard. So if we were to take the, let's say the Xilinx examples I had there, into Kactus, yes, it makes sense in Kactus, but currently we cannot even show what are the extensions. We don't, since they can be anything, we don't know the meaning of them.
Okay, so do you get like the features of the memory maps and things like that? Is that inside the standardized part, or does Xilinx put stuff like that in the vendor extensions
yes,
as well?
we're using the standardized formats for the memory maps and such.
And Xilinx also uses the standardized versions?
To be honest, I don't know what's exactly within those. I think I had
Different.
200.
Okay, thanks.
As far as I know, so I'm using a lot of the Xilinx tools, with the components generated by IP generator, most of the relevant stuff is in the non-vendor extension tools and the standardized tools, but I don't think you will have any luck using a block design generated from Vivado with something else. Thanks.
I can confirm that at least the file listings is standard in the Vivado generated IP-XACT files, because Fuso can parse them.
Oh, Fuso. Any other questions? Then let's thank the speaker again.
I do have one more question. Is it Kactus2 version 3 or is it Kactus 3?
It's Kactus2 version 3.
Cool.
We wanted to make the change to version 3 when we updated the standard. It was a major update.
Okay. Then let's thank the speaker again.